So hopefully a couple of real-life examples will give us an intuition about how to do the problem so that we can use this new formula for a line. So let's say that we were trying to find the equation of a line that has a slope, that would be your rate of change, slope of 2/3. So that's m in our formula, that passes through the point 12, 2. So 12, 2 is going to be hk. That's basically a known point, like 12 hours and $2 or something like that. So we're going to try to write the equation of a line. And we're going to find out with this form, it is incredibly easy to do. So we simply just write our equation, y equals k, that sort of starting y value, plus m, the rate of change, times x minus h. So what do we know in this formula? Well, we know that our rate of change is 2/3. So I'll go ahead and just put that in the place of m. We also know that h is 12. So I would note that up here, h equals 12. So we'll go ahead and just drop a 12 in for h, or when I say drop, I mean evaluate. And then we also know that k, the original y coordinate, is 2. So that would be this, 2. And then we can fill everything else in. If I want to figure out some, moment in time ahead of time, whatever the number of minutes or the number of dollars or the number of problems or something like that, I take the known amount where I'm currently at, I add my rate of change, multiplied by, however many presents or however many hours worked or something like that in the front. And that's my equation for a line. I am done. Okay, that is a linear equation. But it's in a form we haven't really seen very often. We are much more likely to have seen this form, y equals mx plus b, or you can write that as b plus mx. So how do I get to y equals mx plus b from this? Well, if you look carefully, this already has only numbers and x's, and so does our slope-intercept form. So this is a totally optional step, which is to get slope-intercept form. All we really need to do is simply distribute. So here's our equation. Y equals 2 plus 2/3 times x minus 12. So just simplify. 2/3 times x is 2/3 x, and that's a positive. And 2/3 times 12, that'd be 12 divided by 3 is 4, and 4 times 2 is 8, so minus 8. And I have a 2 in the front. Again, you're welcome to do that calculation off to the side, but I'm doing it just to go fast. And then we just simplify. So if we look at that, 2 minus 8 is negative 6, and plus 2/3 x. That is slope-intercept form. So that was actually really, really easy. All we had to do was simply distribute, aka simplify. So use the order of operations and condense your like terms. So let's maybe do one other example. This one says find the equation of the line parallel to the line 10 minus 1/4 x and passes through this point. So if you look at this, the minus 1/4 there is the rate of change. So I know that my line is parallel, which means that it has the exact same slope or the same rate of change. And we're told a point where we currently are, we're at -8, so that would be h, and k would be 5. So all we have to do is write this equation. It's the simplest thing in the world. Step 1, write the form. So that would be y equals k plus m times x minus h. And don't get too lost in this form. Remember, this is like your, at some point in time, amount y value, and you're adding on a rate, and you're doing it a certain number of times, like 4 more packages. Okay, so don't forget where that comes from. Don't let it ever just become a formula. This should make a lot of intuitive sense. Anyway, we'll go ahead and plug in our values. We know that our k value is 5, so let's go ahead and put in 5 for k. We know our rate of change is -1/4, so I'll plug that in as -1/4. And then we have x, which is some future number down the road, some point. It can stand for any number. And then we have h. So h in this case is -8, so minus, and then we'll put in our -8. And that is supposed to equal y. So this right here, technically I could rewrite as y equals 5 minus 1/4 times x plus 8. That is absolutely, totally a legit equation for the line. We're basically just going to subtract 1/4 over and over and over again, some number of times as dictated by x plus 8. So if I wanted to get slope-intercept form, this is the optional sort of third step. So I guess I should have put that was step 2, which was to replace h and k and the slope, or the rate of change. And then if I wanted to finish this problem off, all I need to do is simply distribute and simplify. So 5, and then I have 1/4 times x, so minus 1/4 x. And then 1/4 times 8, but that would be subtraction. So 1/4 of 8 is 2. So it looks like that. And then y equals 3 minus 1/4 x. That is slope-intercept form. Obviously, for those of you who like to have the slope first, negative 1/4 x plus 3, using the commutative property. So we could use either of those two. And that's it.